Oh, I was talking to myself. Oh, that is amazing. How about now? Can you hear me? Just a thumbs up or thumbs down. The same here. All right. Let's see. Okay, now. There we go. There we go. Okay. Some technical difficulties. Let's see. All right. So basically what I was saying, we had a great first day yesterday with an introductory session by Pauline and some builder AMA stories from the ZK Locomotive team. Today we had a security session with Sebastian from Asymmetric Research, and are now waiting for Evgeni. He's telling me he's got some technical difficulties. All right, so people can hear me. That is a good sign so far. All right. Yeah, so to give people kind of an extra introduction to what we're doing here, Sigma, as you know, is a startup program that we are spinning up with the Wormhole Foundation. And it has... yeah, exactly. And it has a couple of parts to it. The first one being the Wormhole, the Sigma Sprint, which is basically what we are doing here right now, and is going to kick in next week on Monday, on October 14th, and is going to go on for about 3 weeks. So during that 3 weeks, we're going to have different builder sessions. We're going to have different... there we go. Evgeni is here.
Can you guys hear me now, finally?
Here, we can hear you and we can see you. Let me pull you onto the stage. There we go. There we
Thank
go.
you.
Hello, Evgeni.
Sorry
How are
for
you?
the delay.
All good. Fantastic. So, Evgeni, tell us, what do you have prepared for us today?
Yes, absolutely. So the goal for today is to first give you an introduction into interoperability. What is it? Why is it? Why does it matter? So I'm going to show you a few slides, and then the next goal is to do a hands-on tutorial. So showcase how to create a natively multi-chain token. So let's say you have two different tokens, and based on that, together we're going to do a deployment by using our native token transfer framework to then actually do the transfer in the end. So after the deployment, we're going to create a very simple UI with our connect widget, and yeah, do the actual transfer of tokens natively between Base and Solana.
Amazing. All right. So I'm going to let you go. You do your thing now. I'm going to mute myself and put my camera off. But yeah, I'll be here if you need anything. So take it away.
All right. Thank you so much. Let's see if I can share my screen. Does that work? Can you guys see my screen and a few slides?
Yes, I can see it.
Awesome. Cool. Yeah, then let's dive right into it. So as I said, first I want to show you a few slides and briefly talk about the state of interoperability and what our native token transfer framework is. So yeah, let's dive in. I guess the first thing that we need to talk about is what actually interoperability is. Because I feel like we say that word so often without even describing what it actually is. So in order to understand that, it's very important to look at the number of active blockchain networks. This is a graphic from last year, and you can already see that there has been more than 100 active blockchains then. So by now, probably it's at 150 or so. So the number of blockchains just goes up and up all the time. So now to look at the next slide, this is from Wormhole Scan, which is an explorer which shows the transfers between those different networks. As you have seen in the graphic before, there is not only a lot of active blockchain networks, but there's also a lot of transfers between those chains. In this graphic from about, I think, 2 months ago, we have seen that about 150 million of volume of tokens would go from Ethereum to a number of different chains. 37% would go to Solana, 29% to Sui, and then to a bunch of others. So I mean, based on that, it's important to see that we have a lot of active blockchain networks. We do have a lot of transfers. So how do we make them as smooth as possible to interact between those different networks, right? And for that, we can then basically define what blockchain interoperability is, which basically means that you would enable isolated blockchain networks to communicate data or assets in an easy way. Right. So for us, it's very important to speak about these 5 pillars, which are our like highest priority considerations for interoperability now after defining what interoperability is. And these 5 things are security, decentralization, user experience, open source verifiable code, and scalability. So any code that any Wormhole core contributors develop is always 100% open source and permissionless. That's very important for us. We do focus a lot on security as well. So we are going to speak about security features that we have as part of our native token transfer framework in a bit. And yeah, the user experience is also, as I said, very, very important because I mean, if something is open source and secure and decentralized, but building on top of it is very complex, then probably not a lot of people will use it. So we're gonna see later on that we try to make it as easy as possible to interact with our native token transfer framework. For that, we created a CLI, so you would not even need to interact with the contracts directly. You could, as I said, all the contracts are permissionless and 100% open source, so you could interact with the contracts yourself, but you could also use our NTT CLI to then do the deployment, which we are going to do together in a bit as well. Right. So the next thing which is important to speak about is why interoperability is not or still has issues today. So that's why we call it the cost of interoperability. The 3 main things that are introduced by wrappers are one, asset fragmentation. So it's very hard to tell sometimes if you come to a new chain what the canonical asset for a chain is. So if previously wrappers would wrap tokens based on the chain they would come from, because the tokens would be not native to the chain itself, but wrapped by using a like wrapper contract around it, then it would be a number of different assets on the chain. So let's say there would be USDC from Sui, USDC from Celo, all being on Ethereum without enough without enough liquidity. So that would be like one big issue. So there is asset fragmentation, which would be introduced. The UX would be hard because it's hard to understand what the canonical asset is. And there will be no composability because of the lack of liquidity. So it would be hard to use those wrapped assets, or I would even say impossible, in any kind of DeFi protocols like lending, or even doing swaps would be hard because of no liquidity. The slippage amount would be too high. So this is definitely things that we try to consider when creating our native token transfer framework. So yes, this is kind of an image to describe like how it actually looked like. It's very unclear to understand. Is it the USDC that I want, or is it the one from a chain that I don't want? So it will be like 40 versions of USDC on one chain that all be wrapped using different wrappers. And that's why we developed, or like with these considerations, we developed our native token transfer framework, which we're going to use today, as I said, to do the actual deployment, to deploy tokens natively and make transfers possible natively between different chains. So NTT is an open source framework that is just a way to how Wormhole proposes to do these transfers on chain, but it's very flexible. So you will see later on that you are not limited to one way to do it, but it's just a framework to provide you with as much flexibility as possible for the long term. So this brings me to the next question, which is how to deploy a native multi-chain token. As I said in the beginning, the goal for us is to not have wrapped tokens anymore, but to have a native token which would be able to be transferred between multiple chains. Today we're going to choose Base on Solana and have a token which can be transferred without being wrapped at all and not to run into all the limitations with wrappers that I mentioned before. Before we start that, let's talk about what a native multi-chain token is in the end. Here you can see that this is an UI that we're going to build, or like a similar UI that we are going to build with our React widget in a little bit. And here you can see that the W asset is native on Solana and to Base. So it's not wrapped, but it's actually native and can be transferred across multiple chains without having centralized wrappers like we spoke about before. Which then brings me to the second part of like another question, which is how to deploy a native multi-chain token with customizable security models. As I mentioned before, the native token transfer framework is very flexible. So you are not limited to one model of deploying it, but to different ones. And I would like to showcase you today the two most used ones that we have incorporated as well in our CLI. So exactly what are even customizable security models? For that, we need to deep dive into NTT. Right. So as I said, the framework is very flexible. It's important for us to have different models, but also give like kind of prevent all the bad, well, not bad, but like less flexible qualities of wrappers. And for that, NTT preserves three very important things, which are one, the token ownership. So with wrappers, the token would be not, you would not, the builder would not control the token itself anymore. With NTT, you preserve full control over the token. You can still adjust the metadata the way you want it, which would not be possible before. You have full upgradability rights, and you can customize it as much as you want. So, for example, anything, let's say governance, restaking tokens, stablecoins, it doesn't matter. The framework will work across all tokens that a builder will want to use. And as I said, the builder would still have full control over the token in comparison to the wrappers, where the control will be lost and the wrapper contract would have full control over the token. Yeah, so after basically speaking about this, let's talk about the different models. The two main ones that we see integrators used are one, the burn and mint model, and two, the hub and spoke model. So first, I want to say that it's important to mention that you are not limited to these two models. You can think of any functionality you want and build it based on the NTT framework. But these are the two models that we just see the most, and that's why we incorporated them in our current version of the CLI to make it as easy as possible to deploy them. The burn and mint model is usually used for new tokens. So let's say you want to have a new token deployed completely from scratch on Arbitrum and on Solana. You could go ahead and do that with the burn and mint model, and then whenever tokens would be transferred from Arbitrum to Solana, then they would be burned on the source chain and minted on the target chain. The hub and spoke model is usually used for tokens that are existing and don't have the needed functionality for the burn and mint model, because in order to use a token for burn and mint, it needs to have a burn function and a mint function. And sometimes we see integrators that just have a token already, and it's not upgradable anymore, so they cannot add any burn and mint functionality to it. So they would then go for the hub and spoke model. And the hub and spoke model works in a way that you just you pick your hub chain, which is usually the chain where you have your existing token, let's say Mantle, and you want to go from there to a bunch of spoke chains, which then will work in the burn and mint fashion as well. So let's say we pick Mantle for the hub chain and Solana and Arbitrum for the spoke chains. Then whenever we would transfer the token from the hub chain out, then the token would be locked on the hub chain because there is no burn and mint functionality of that token, and then minted on one of the spoke chains, so Arbitrum, Solana, or any other supported chain. And on the way back, it would be then burned on Arbitrum or Solana, and then unlocked on Mantle. Right. So that would be kind of the way how like we propose two of the models to work, or like two of the models that you can choose for your token to be natively multi-chain. Next up, I would like to speak to you about more security features. Let's look at the in-depth security mechanisms that we...
Evgeni, I'm sorry to interrupt you. We have a question in the chat that I think is really good to answer at this point.
Yes. Yeah. Let's see. When you say you're not limited to these two models, do you mean one can extend, manipulate, and see framework to add new models of NTT? Will that be based on using Wormhole contracts for message passing? Yes, absolutely. Great question. Thanks for asking. So the NTT framework is, as I said, 100% permissionless and open source. So you could go ahead, in order to do that, you need to create your own NTT framework, right? No, you don't need to create your own NTT framework. You could just go ahead and interact with the contracts that are deployed on chain. So we do have an example repository that I can link later, where you could see implementation of the framework for the burn and mint model or for the hub and spoke model. So you would see how, like, which contracts, how contracts look like on chain that are built based on that framework. But if you want to have additional functionality, you could just modify the contracts and deploy them yourself. So let's say we've seen integrators that wanted additional yield for a token during some locked period. So let's say you choose a hub chain, but when your tokens are locked, you still want to give your users some yield during the period where they are using your native token on one of the spoke chains. So what they did is they went and modified the contracts that would be taking care of the locking to just like give out yield during that period for the same token. So it's up to you. You can modify the tokens. The framework is just kind of our proposed way of how you can do it, but as I said, it's open source, so you can modify it as much as you want. Does that answer your question? Would that be based on the Wormhole contracts for message passing? I'll get to the message parsing part in a second. You can use Wormhole verification, but you don't need to. So since it's an open framework, you can use any kind of other general message parsing framework, even outside of Wormhole for that. But let me get to that in a second. It's part of the presentation. Okay, so I hope that question was answered. Okay, I don't see anything in the chat, so I continue. Cool. So I was talking about the security mechanisms that we have in place for the NTT framework. One is the on-chain rate limiting. So, what we have on contract level is rate limiting for outbound and inbound limits. What it means is that you can set up amounts of the amount of token that could go either out or in from a specific chain. It's optional, you don't need to specify it, but let's say you just want to have 2 million of your token that would go out from Arbitrum to Solana on a daily basis, then you could do that and it will be enforced on contract level. And we also have that as part of our CLI. In fact, we are going to, I'm going to show you how to actually set the rate limits with our NTT CLI in our tutorial session in a little bit. And the second thing that we have as security mechanism is our global accountant, how we call it, which basically is enforced by the Wormhole guardians, and it makes sure that the amount of tokens that are transferred into an ecosystem is not bigger than the amount that gets transferred out of an ecosystem. So that's kind of also one more security mechanism to enforce supply balance invariance. So meaning to make sure that you don't have 5 million USDC going out of Arbitrum, but just 2 million into Arbitrum. So just to sanity check to be sure that security is even enforced on even more. Right. And now let's talk about the verification mechanisms that I described in the example for the questions before. So with the NTT framework, you don't have any kind of login. So you can use any general message parsing that you want. As I said, for example, you can set any kind of thresholds for verification. This is also completely flexible. You can say, for example, Lido did a 2 out of 2 verification with Wormhole and Exceler. So they deployed NTT tokens, but they specified that for any kind of transfer from the BNB chain to Ethereum, not only Wormhole needs to attest that a token can actually be minted, but also Exceler. So they set a 2 out of 2 verification mechanism to have even more security in place. And so it's important to say that even if Wormhole would not exist anymore, you would have no lock-in and you could still use the NTT framework, just let's say with Exceler or any other general message parsing solution. So I guess it was very important for us to be as flexible as possible and just provide a framework of how to do that with the highest flexibility in mind. That's just a screenshot that I did where you can see that you have all the necessary contracts for the Lido example for their BNB to Ethereum transfers. You can see that there is a token for both chains. There's an entity manager that we are going to deploy in a little bit on both chains. And then the interesting part is that you have 2 different transceivers. You have the Wormhole transceiver and you have the Exceler transceiver. Transceiver is the contract that basically is doing the verification itself. So it makes sure that, okay, something happened on chain A, so I attest, or I'm sure that based on the attestation, I can do an action on chain B, on then the target chain. And for that example with Lido, they deploy transceivers for Wormhole general message parsing and also for Exceler, which is super cool and in my opinion a great example of how we can increase security in our industry even with different different kind of solutions that work together for deployments. Right. So this was the introduction. I see there's another question in the chat. When the transfer of token happened from one chain to another, what happened to the block on the chain from which it got transferred? What do you mean by the block? So NTT is based on finality. So the chain is before, sorry, okay, one step back. Before we can go from Arbitrum to Solana, what happens when on Arbitrum we have a token that should get burned. Wormhole, the wormhole attestation will only say, okay, a token was burned if finality was reached. So on Ethereum, it's up to 15 minutes, which a user would need to wait until to be like almost 100% sure that the token has actually been burned on Arbitrum or whatever to then get minted on Solana. So if you're referring to that, the block itself would just have entries of a token being burnt on one chain and then minted on the other chain, which is completely independent from Wormhole. What Wormhole just is basically providing is a mechanism to be sure that something happened in a decentralized way, and then to trigger an action on the other chain after being sure that this action was actually happened there. Okay, looks like we are good to go. Any other questions before I would start with the demo? No? Okay, cool. So the goal for the demo part is to show you how to basically, as I said, deploy a natively multi-chain token. In order to save some time, I deployed a very plain ERC20 token to Base. So before I start, it's important to say that all the steps that I'm going to perform today or I did before are all in the docs. So the goal for me is for you to be able to reproduce the deployment without even the need of looking at the video. I mean, of course, you can later on look at all the steps, but what I'm going to do is just do basic copy and paste and explain what I'm doing from the docs to the CLI, to the terminal by using the CLI. Easy and fast it is to do the actual deployment. So for that, can you share the link of the token you deployed on Base? Of course. I called it the Sigma Workshop token. Let me share the links later on. I'm going to share all of them after the presentation. So what I did is, I mean, first of all, I have the NTT CLI deployed, not deployed, sorry, the NTT CLI downloaded. So can you actually, you can see my screen, right? Still, the terminal, just start checking if you can see what, Urban? Or someone in the chat? Can you?
Yes, it works.
Okay.
I can see it. I'm
Cool.
sorry, I was clicking the wrong button.
All good, all good. Just to double check that switching windows works. So exactly as I said before, what I did is to create two tokens just to save some time. So all the steps are in the docs again. We have the example NTT repository linked here, which is just the basic, just a repository which you can clone, which has a very basic ERC20 token that has a burn and a mint function. In case if you just want to play around with it and you don't need specific methods for your token yourself. So what I did is just I cloned this repository. Let me go through the steps really quickly one more time. I cloned the repository and I executed the deployment and minted some tokens. Just called it Sigma Workshop token, as you can see, just before the workshop, to just be able to show you guys how to do it. And I did the same on the Solana side, where we also have all the steps in our documentation. So I just created a very basic SPO token with no functionality at all at the moment. Just created the token and minted myself some tokens. Yeah, we have a supply. That's good. And now what I would like to go and show you guys is the actual Wormhole related steps, because before deploying tokens is independent and works with the CLIs, with the respective CLIs of the chains. So in order to do that, let's go and look through all the steps. So after having the CLI downloaded, you would go ahead and create a new NTT project by just saying NTT new. NTT new, let's call it Sigma workshop deployment. Next up, we need to specify which whether we want to have the token on testnet or mainnet. NTT init testnet. This step is very important, because this step gives us our important configuration file, which is called deployment.json. Right now, this file is empty because we did not specify any of the chains or the tokens on the chains that we want to use to actually perform the transfer. But after doing the next steps, you will see that this configuration file, deployment.json, is going to get populated if the deployment works. We're going to specify which token you want to use. It will have the two main contract addresses, which is the entity manager and the transceiver, and it will have the actual rate limits that we want to specify from each chain. So let's go ahead and do that and start with our EVM side. So the next thing that we want to do is execute our add chain command, which is it too small? Let me actually make it bigger. I hope that's big enough. So what we want to do is to execute our add chain command. This add chain command is going to specify which token we want to use, which mode, and which chain. So as I said, I have today deployed the token to Base. So we're going to say Base Sequoia is the chain that we want to add because that's where we have the token. We want to use the latest contract version. We have, for example, on the Solana side, we have two versions of the NTT CLI, version 1 and version 2, and we have version 2 because we introduced token extension support on the Solana side. But for just usually the latest version works if you want to just have basic functionality. So we say we want to use Base Sequoia, latest contract. Today I'm going to show you how to use two new tokens in the burn and mint model because I deployed new tokens, so it's I'm not limited by upgradability of the token at all. And what it needs as the last step is the token address, which I'm going to copy from here, from our Sigma workshop token. All right, so this is doing the Base Sequoia part. If this deployment goes well, all after it downloads all the dependencies, then we will see that the deployment.json, which is our important config file, is going to be not empty anymore, but will have more fields based on our token. Let's see. Let's wait a second until everything gets built and deployed. In the meantime, let me talk about the next step, which is going to be the Solana part. As I said, we already created a very basic SPL token, and the Solana section is going to have a few more steps in comparison to the Ethereum part because, let me just check if that worked. Yes, that worked. So the Solana section is going to have a few more additional steps in comparison to the Ethereum part because on Ethereum, we cloned this repository that this example NTT token repository that I mentioned, which had burn and mint functionality for the token itself already built in. And on Solana, we just deployed the regular SPL token. But in order to be able to actually mint tokens, we need to delegate the token mint authority to the NTT program that we're going to create. So for that, on the Solana side, we need this 3 more steps before we can execute the add chain command, which I'm going to show you guys how to perform. So first, let's look at our configuration file again. As you can see now, we have way more information. Before, the deployment.json was empty, but now after specifying our base Sequoia token, we can see that we have the information about the owner, which is the wallet that I use, the manager, the entity manager that is needed, the transceiver, and some limits that we are going to modify in the end before actually pushing everything on chain. Right. So as I said, as the next step, let's do the Solana part. If the Solana deployment works, then we're going to see that this deployment.json gets another entry, not only base Sequoia, but also Solana. So let's go ahead and change directory into the Solana directory where we have a wallet created before, which has 11.2 Sol. So first we are going to grind a new key pair for the NTT program. Let's just call it NT. Then we are going to derive the token authority. So we need to derive a PDA of the newly generated program ID. NTT Solana token authority. And we need the program key pair. Whoops, sorry. Without the JSON ending. This is what we need, which is the PDA of the newly created NTT program. And in the last step, we need to set the SPL token mint authority to that newly generated PDA. So for that, we are going to use the SPL token CLI. We need to authorize the token address. Let me copy the token address. Specify that we want to delegate the mint authority and the newly derived PDA. Cool, that worked. And now we can actually go ahead and perform the add chain command that we did on the base part, also for Solana. So we're going to say entity add chain, Solana. We again want burning mode. We want the token. Let me copy it from here again. We need to specify our payer, which is going to be the wallet that I just created before for this workshop. This is the path of the wallet. And we need to specify the program key, which is the newly created NTT program that we have in this directory here. And all right, and before I execute that, it's important that we don't execute it in the SVM token directory, but in the actual NTT directory that has our important deployment.json file, which hopefully after this deployment works, is going to have one more entry. So not only base Sequoia, but also Solana. If we didn't mess up any of the paths. All right, this is compiling. Any questions in the chat so far? No. Okay. So just to recap, what we did with the CLI is to specify the token, the chain, and the model that we want on the base part. We did a few more steps on the Solana side to delegate the token mint authority to the newly generated NTT program. And now after, if hopefully this deployment to Solana works, what we're going to do is to look at our deployment.json and specify which rate limits you want to have, because by default we have 0 inbound limits, meaning that any transfer of tokens into a chain right now would be rejected because we didn't specify any rate limits. I see a question. In the previous example, include the addresses indicating we can, for example, have one out of two thresholds by changing it back to one. So the if you want to have additional attestation with Xlr, this functionality is at the moment not supported with the CLI. For that, you would need to go and deploy the contracts yourself. We're currently like with the next version of the CLI, we are probably going to release that functionality as well to have like multi-transceiver support, how we call it. But at the moment, you would need to not use a CLI for that because it's more of a complex example, but actually deploy managers and transceivers yourself. But the Lido example is open source, so you could go ahead and also just take a look at how Lido did it and just modify it for your needs. Is this process only possible from the CLI? Can we do the same with contracts on chain? Everything that I show you with the CLI is possible, or actually it's based on the actions from contracts on chain. So you don't need the CLI at all. It's just a way to make it even easier for you to interact with NTT. So this seemed to have worked. If we now look at our deployment.json, before, let me see, before it had just one entry for Base Sequoia, and now it should have a second one for Solana. So that worked. So as you can see now, we have two different chains, Base Sequoia and Solana's DevNet, which has the manager address, both of them, transceiver address, the tokens that we specified, and the rate limit, as I said, that are zero inbound by default. So let's go ahead and actually modify the deployment.json file to increase. Oh wait, actually before we do that, let's first let me show you in the configure sections which other commands we have. There is the NTT status command, which will tell us now that we didn't cross-register both chains with each other, probably. Then we have the NTT pull command, which actually sets up. That's why I didn't change the rate limits before executing that command, because the rate limits need to have the appropriate number of decimals depending on the specific chain, which are different for Solana and Ethereum usually. So as we can see now here, entity status tells us that there is a missing peer, manager peer for Solana and Base Sequoia. So we didn't cross-register both deployments with each other, which we're going to do in a second. So after running entity status, we will do entity pull to give us the needed decimals. Now we can see that we have the needed decimals based on every chain, and now we can go ahead and adjust them to then, like in the end, after adjusting the rate limits, do the actual transfer of the tokens. Just sending it to a random number, 1,000. So this would mean that on a 24-hour basis, 1,000 of the specified tokens can be transferred inbound from Base Sequoia to Solana. Let's double check if that worked. That worked, cool. And the last step is just going to be to actually do the deployment to cross-register the contracts with each other. For that, I need to specify the path for the gas payer, NTT push -- payer. Please use my newly created wallet. Right. So let me look at the questions. Language support for NTT, will Rust have support? So our contracts on Solana are in Rust and on EVM on Solidity, but the framework is not limited to any languages. You can use it with any languages you want. Just deploy contracts in the NTT fashion, and that's basically it. So the CLI works with just from the CLI, right? But the languages that you want to use is up to you. Is there a guide on how to deploy NTT tokens with contracts on chain? Not at the moment, no. At the moment, we just have guides for how to use our CLI, and then how to use either our TypeScript SDK or our Connect widget, React widget, to interact with it. But it's good feedback, like that we should probably do also on-chain example directly without the CLI. Why do we need limits? Can we make it without limits? Yes, sure. Again, as I said, everything is open source and permissionless. You don't need to specify rate limits. But since we have that option as like built in our CLI, I just wanted to show you how to do it today. So just to basically summarize what we did, because we are already on the entity deployment part. So in the last about like 20 minutes, what we achieved is to deploy entity managers for two chains, Base Sequoia and Solana. We can see in the deployment.json file that we have all the information, including the manager, the transceiver contracts, and we specified inbound and outbound limits. So for now, you see that we just have one inbound limit specified for Solana on Base Sequoia, but if you, let's say, want to have support for additional chains, so let's say you do an NTT add chain command for Arbitrum Sequoia, then you would see one outbound limit for Base Sequoia, but two different inbound limits, one for Solana and one for Arbitrum Sequoia, which you can then modify yourself the way you want. And that's pretty much it on the NTT deployment part. Any questions so far? Can we do that with the TypeScript library? Yes, so you can, depends. The deployment itself can be done even without entities, the CLI at all. The library has functions for transferring or for adjusting rate limits. But I need to double check if it actually has scripts to do the actual deployment. I'm not sure about that. But you can just interact with the contracts yourself without the need for the TypeScript library. All right. We still have 8 more minutes, so what I would want to show you in the end is just how to do the actual transfer based on this deployment that we just did. And for that, I want to show you our NTT Connect repository. It's also linked in our documentation. So here in the post-deployment part, you can see that there is either the NTT Connect demo, which is this React widget, or the TypeScript SDK demo. The goal of this was to make it as easy as possible, again, for you to just clone the repository, put in the needed information based on the addresses that we have specified, or like that we can see from the deployment.json, and then to actually perform the transfer. So for that, I'm going to, as I said, clone this repository. Let me pull this. And what I usually do, let me first install the dependencies. So what I usually do to make it easy is I just copy the deployment.json. It's not, you don't need to do it, but then based on this, you can copy and paste all the needed addresses from the token manager and transceiver inside the Connect configuration. So let me just create an example deployment.json file here. This is the content that I copied from the previous deployment. And while the dependencies are loading, okay, they're loaded. So now the only thing that you need to do is to specify which networks you want to use, and then just copy and paste over the information, as I said, from the deployment.json config. So today we want to use Base, Sequoia, and Solana. Base Sequoia, Base Sequoia. Cool. And now we're just going to, as I said, copy and paste all the needed information. So here we need the entity manager address for Base Sequoia. So we check our config, Base Sequoia, manager. Cool. The transceiver from Base Sequoia. Here's the transceiver. Copy it over. Same for Solana. The manager, the transceiver. And then we need the token itself. So again, this is the token on Base Sequoia and the token on Solana. And that's all. That's already it. That's it. Let's just modify this. Let's do Sigma. All right. So just within 5 minutes of cloning a repository, taking the configs from our deployment.json inside our Wormhole Connect config, we were able to create a very easy UI. Let me open my test browser. And that's pretty much it. So by default, you have wallet integration support. So as you've seen, I didn't do any kind of wallet integration steps, but I was able to connect my EVM wallet, MetaMask as an example, Solflare on the Solana side. We have our two networks specified, which is Base Sequoia and Solana, and we can choose any assets that we have in our wallet to then send them across. And that's pretty much it. Yeah. So I guess maybe I used a different wallet because it doesn't show me my token. Base Sequoia. Did I specify the correct token? 1 second, let me just double check. Token address. Base Sequoia, Solana. Oh, okay. That's the reason. I forgot to specify Base Sequoia here for the token ID. So now it should show us the right token. Let's see. Cool. So we have our token here and would now be able to go ahead and transfer the tokens here. We are out of time, 2 minutes, so I'm not going to actually do the transfer because it will take up to 15 minutes based on the finality from Ethereum to do the transfer, but this is everything that you need to perform the transfer yourself. Yeah, so let me just do a final recap. What we did today is to basically take two plain tokens that have been deployed on Base and to Solana, use the NTT CLI to make them natively multi-chain by specifying that we want to be in burning mode. Between those two chains, we did the deployment of the entity manager and the transceiver. We specified the rate limits, which you can see, which you could all see in the deployment.json config file. And then we used our React widget in order to very quickly spin up a very basic UI. You can modify it as much as you want, but this is just kind of a very fast way to get started in order to have wallet support, wallet connect support, and to then be able to specify networks and then do the actual transfer in the end. Yeah, and that's pretty much it for today's workshop. Any questions?
I mean, you've been answering questions nonstop pretty much for the last hour, so I
Yeah,
think
maybe.
I think we're good on the questions. No, really good job, man. I really enjoyed this presentation. I think people were highly engaged. There's a lot of good questions here. Everything was also multi-streamed to YouTube. The recording is going to be available later on. But I think, Evgeny, this is a workshop that you've given a couple of times already, right? So people might have seen you do this. So in any case, thank you very much, Evgeny. This was really, really good. I think extremely insightful. Evgeny is also going to be around the whole Sigma Sprint event. So if you need him, yeah, go ahead and ping him because he doesn't have a lot to do. Yes, he does. But yeah, in any case, both me and Evgeny, as well as Pauline and other people are going to be around for the whole event. We're here to help you, to make you successful. People are asking for your Twitter. Maybe you want to share that as well, Evgeny. And there you go.
That's my Twitter, and also have the same name on Telegram. So feel free to shoot me a message on Telegram or on Twitter anytime if you have any questions.
There you go. There you go. That's it. Let's wrap it up. Thank you very much, Evgeny, again. Thank you very much, everybody who tuned in. We're going to be around, and I'll see you tomorrow. Yes, we've got 2 more sessions scheduled for tomorrow. So Amazing. Thank you very much. Have a good one.
Thank you guys for your time.